I have always heard that you should never compare apples to oranges. So I'm going to start off this lesson by comparing apples to apples. Later on, this may help you remember how to compare and contrast different isotopes of atoms. So more specifically, we are going to describe 3 different types of apples: the crab apple, the golden delicious, and the Granny Smith. All very different, but all still apples. So what makes them apples? They're all biologically named Malus domestica. They grow on trees, they have stems, the list goes on. But what makes them different? First of all, the crab apple is very small. It's red in color and it tastes quite sour. And for the purposes of this lesson, we are going to give it a fictional mass of 1 AMU, which we'll call the apple mass unit. Whereas the golden delicious is medium-sized, yellowish in color, tastes sweet, and we're going to give this a mass of 2 AMU. Finally, the Granny Smith is large, green, and tastes sour. We will give this apple a mass of 3 AMU, so it weighs 3 times as much as the crab apple. They're all similar in that they're apples, but they have many different characteristics. So if I were to ask you, what is the mass of an apple? What would you say? 1 AMU, 2, or 3 AMU? Well, it all depends on which type of apple you're referring to. Now let's compare atoms. In a previous lesson, you learned about the makeup of the nucleus and how it contains both protons and neutrons, both of which are the primary contributors to the mass of the atom. The mass of the electrons is not significant enough to keep track of. The number of protons an atom has will determine which type of element it is, and all atoms of the same element will always have the same number of protons. Where things get interesting is in the number of neutrons in the nucleus. We're going to use hydrogen as our example. Hydrogen has 3 major isotopes. Remember that isotopes have the same number of protons, but different numbers of neutrons. The most common isotope of hydrogen has only 1 proton and 0 neutrons. If both protons and neutrons have a mass of about 1 AMU, atomic mass unit, the mass of this atom would be about 1 AMU, just the mass of the proton. This isotope of hydrogen has a special name, protium, and it makes up over 99.98% of all hydrogen atoms. The next most common isotope is called deuterium. Its nucleus contains 1 proton and 1 neutron, so it has a mass of about 2 AMU, 2 atomic mass units. It makes up less than 0.02% of the population of hydrogen atoms. The last isotope is called tritium, and it has, as you may guess, still only 1 proton, but it contains 2 neutrons in the nucleus, giving it a mass of 3 AMU, 3 atomic mass units. There is very little tritium that exists, and it's very unstable. So if I were to ask you, what is the mass of a hydrogen atom? You would need to know which isotope I was talking about, protium, deuterium, or tritium. Remember that these 3 isotopes are all chemically